Hi everyone. So today I'm going to discuss one of the very good problem, which were asked in Gate 20223, okay, from our classroom directly. So I hope all of my students might have done this problem correctly, right? So this problem was direct, right? If you see, if you see this problem was question number 64, and this was asked for 2 marks, okay? So what problem is there? Let's read the problem. This problem was from analog circuit, and they have connected current mirror. Already this kind of problem has been asked in 2019 when IIT Madras conducted gate paper. So as you can see, if you have done wonderful practice on PYQ, right, so you can easily solve any kind of questions, right? So you can see this question was directly asked, and okay, I believe many of you might have done correctly, right? So in the circuit below, the voltage VL we have to find is, okay, rounded off to 2 decimal places. So needless to worry about that if you get the answer not in decimals, right? Okay, so let's begin with the problem. So as you can see here, first transistor you see here. So this is connected from, you can see this is gate and this is drain. Gate and drain are connected means they are in saturation, okay. So if this current is flowing, okay, if you see just this part of the circuit, right, the first part of the circuit, that is going to be a current mirror, right. So 1 milliampere is flowing through this first transistor, okay. So what should be the current flowing through this transistor? You can say the transistor, W by L, whose ratio is given as 10, right? And so whatever current will flow here, the same current is going to be flowing, okay, through this transistor as well, right? Okay. So, but as you can see, their W by L ratio is different, right? So current is going to be different also. As we know that in saturation, what is the equation for saturation? ID equal to 1 by 2, mu and COX W by L VGS minus VT whole square. So you can say that ID is proportional to W by L, right? ID is proportional to W by L. So if you know the W by L ratio for individual transistors, so you can scale the current as well, right? So if, and suppose the W by L ratio, all the parameters are same for both the transistors. So whatever current is 1 milliampere is flowing through first transistor, the same current will be copied, that is known as the current mirror, right? Okay. So for this transistor, the W by L is 1, and for this transistor, W by L is 10, right? So you can now relate, okay. So this current is going to be how much? Okay, this current will be what? Okay, if 1 milliampere is flowing through this, what will be this current, right? That you have to find out, okay. So let us find out. As we know that ID1, okay, suppose this is ID1 and this will be ID2, you can say, okay, and the ratio is 10 by 1, okay, W by L ratio is 10 by 1. So ID1 upon ID2, okay, equal to what? W by L 1 upon W by L 2, you can say, then you can find out easily, okay. So what will be the current here? So this W by L, if W by L is there, that is 10, yeah. So I believe anybody can solve this kind of question, okay. So this will be 10 milliampere, right? So this is going to be 10 milliampere, okay. So you can say this is going to be 10 milliampere, and it will be flowing through this 10 milliampere, okay. So this is 10 milliampere, and from here also 10 milliampere, okay. So now you see, again you have to find the current through this transistor, okay, which is connected in parallel, okay. All the gates are sorted, you see here. So you have to find this current, okay, through the transistor which is having the aspect ratio 7, okay. So you have to find this current with respect to first transistor, that is W by L, which is reference transistor, okay, which is diode connected also, and it is in saturation, okay. So it is going to be 7 milliampere, okay? That you have to understand, because W by L ratio is 7, and for 1 milliampere transistor, you see W by L is 1, right? So it will be 7 milliampere, and here 10 milliampere. Now through this transistor, W by L equal to 7 milliampere is flowing, and here you notice W by L is 5, okay, and it has 10 W by L, right? So again this current through this transistor, okay, they haven't put the name of the transistor, they have just given the different aspect ratios, okay. So this is going to be what this current through this transistor, let me write here, that is going to be 10 milliampere into 5 upon 10, okay. So you can say 10 gone, so it will be 5 milliampere only. So you can say that 5 milliampere current will be flowing through W by L equal to 5 transistor, okay. It's okay. Now if you know the current through this branch, so you can easily find out the VL, and VL is nothing but VL is nothing but 1 kilo ohm into whatever current is flowing through this, you can say Ix, okay. So this 7 milliampere current is coming, okay, and this 5 milliampere is going, so the left is 2 milliampere current into 1 kilo ohm, this is 2 volt, right? So the answer for this question is 2 volt, okay. So if you know the simple relation that ID is proportional to W by L, okay, in case of saturation, or you can also say that in case of linear also it is proportional to W by L, okay. But in this case the transistors are in saturation, okay, because you see here this transistor, I mean this gate and drain are sorted, okay. So if the gate and drain are sorted, it means they are in saturation region, okay. The answer for this question will be 2 volt, right? And they have asked rounded after 2 decimal places, so you don't have to become panic during the gate examination. So this was the question which we can do within I think 10 to 20 seconds. You have to also be very careful, okay. Otherwise many people what they do is they calculate this current, okay, with respect to this, but these transistors are connected in parallel, okay. So one current mirror and there is a second current mirror, right? But for first current mirror there are two transistors which are connected in parallel, okay. So I hope this solution makes difference, okay. So you have to remember this relation, okay, 1 inch long equation, okay, where current channel length modulation is neglected. If channel length modulation will be there, then you can say that the relation is going to be what? ID W 1 by 2 W mu n Ux W by L, okay, mu n Ux W by L, okay, VGS minus VT whole square, okay, 1 plus lambda VDS, okay. So here lambda is going to be what? Lambda comes when there is a channel and modulation, okay. So we will meet in the next session. Again we will take one question from analog circuit, okay, recently asked in the gate 2023 from our classroom only. So I'm going to show you all the question has been asked from our classroom, whatever subject we have taught, like communication, electromagnetics and signal system, okay, and analog circuit. Let's meet in the next session.